Alright, so welcome to this video. In this video we're going to go ahead and discuss section 7.4. The title is double angle and half angle identities. And so we're going to go ahead and begin by looking at some double angle identities. And they're all written for us here. Notice that we have three different identities for cosine of 2a. And I'll show you again where these identities come from in just a bit. And then we have one identity for sine of 2a, and then one identity for tangent of 2a. And we just finished up the section on the sum and difference identities, and so that's kind of where these five identities stem from. And so I'm going to show you really quick the cosine of 2a and just how that comes to form, or how we get this cosine squared minus sine squared out of it. So let's just look at cosine of 2a. Cosine of 2a can be written as cosine of a plus a. I mean, a plus a is in fact 2a. And if we think back to the previous section that we had, we dealt with identities that look like this. This was a sum identity, or sum and difference identities. And so if you just remember, and I'm going to write it off here to the side, but in the previous section, we had written something like this, that cosine of a plus b was equal to, and I have it here, it is cosine of a, it was cosine of a, cosine of b, and then we subtracted sine of a, sine of b. Let me just scoot this over a little bit. Sine of b. And if you notice what we have here is really just kind of the same thing. Here's our a, and technically we could label this as b, and so we just apply the formula. And if we would apply the formula and think about this, let me go back to the different color, but if we think about this angle as a, and if we think about this angle here as b, and kind of just fill in a and b respectively, let's see what we get. Well, we would have cosine of a times, and then cosine of b, but for us b is just another a, so it's going to be another cosine of a, and then minus sine of a, and then sine of b, but again b is just a again in this example. And cleaning this up, cosine a times cosine a, this is simply just cosine squared of a minus, and then sine a times sine a is just sine squared of a. And so that's how we get this formula here, this identity there. And so cosine of 2a is simply just cosine squared minus sine squared. Now the question is, well, how do we get these other ones from what we just had? Well, you need to think back to two sections ago when we looked at the Pythagorean identities and we discussed this important one. We had sine squared of some angle theta plus cosine squared of some angle theta is equal to 1. And so if I think about solving for cosine, so if I move the sine squared to the other side, in other words, if I get this guy right here and I subtract him on both sides, then we know that cosine squared is equal to 1 minus sine squared. And so what I could do is I could simply just replace cosine of squared a, or I'm sorry, I put an a here, these right here, just so that I can be clear. These should all be thetas, but again, it really doesn't matter, but I need to be consistent there. So I could come back over here and say, okay, well, instead of cosine of squared a, I can write 1 minus sine squared, and so that's what I'll do here. So I have, let's see, equals 1 minus sine squared of a, and then I'm going to bring down this minus sine squared a that we already had. And then if I ask myself, well, if I combine some like terms, how many sine squared a's do I have? So I have negative sine squared a minus sine squared a. That's simply just going to give me, let me do this in orange, that's simply going to give me 1 minus 2 sine squared a. And so that's where this guy will come from. And we can kind of play the same game and do the exact same thing and say, okay, well, what if I solve for sine squared instead? So sine squared of theta is equal to 1 minus cosine squared of theta. And that just comes from, again, getting this cosine squared and moving that to the other side. So if I come back up here to this identity right here that we had, I'm going to go ahead and erase this really quick. And I say, okay, well now let me go ahead and replace sine squared with 1 minus cosine squared and see what happens. So if we do that, then we would have, okay, well we would have cosine squared of A minus, and then here we would have 1 minus cosine squared of A. In fact, let me go ahead and redo this and keep it consistent on the color scheme here. This would be equals, and we would have cosine squared of A minus, and then again, the only thing that's getting replaced is this part here, which is this part here in green. So we have that, and then the only thing that we have to do is just simplify and maybe distribute. So a negative times a 1 is negative 1, a negative times a negative would be a positive cosine squared, and what that would leave us with is 2 cosine squareds of A, and then again we have this minus 1 here, and so that's kind of where this formula right here comes into play. And so all I'm doing is just showing you that these 5 identities that you see here, they all stem from what we've seen so far already. So it's kind of just putting all the identities that we've been working with together to create some more, and these just happen to be called double angle identities. In the next video, we'll actually look at an example where we apply these identities and we get to see how we use them. So stay tuned for the next video.